So in Lewis theory, we're looking at the valence electrons and we represent them as dots. So to write a Lewis structure for an atom, you take the element symbol and you put the number of valence electrons as dots around that element symbol. So if we look at oxygen, so electron configuration for oxygen. So that should be 1s2, 2s2, 2p what? 4. These are the valence electrons that oxygen has. So when we write a Lewis structure for oxygen, we write the element symbol, and then we put how many dots? 6. 6 dots, 6 valence electrons. I don't usually go over this, but I'm going to show you this because it's cool. So if we look at the orbital diagram and put the 6 electrons in there, 1, 2, 3, 4, 5, 6. These 2 electrons are paired up, those 2 electrons are paired up, and then there's 2 electrons that are unpaired. That actually corresponds to the dots here. There's a pair here, a pair there, and 2 singles. These atoms react in a way so that they can get 8 electrons. That would correspond to 2 dots on top, 2 on the bottom, 2 on the right, 2 on the left. And so we don't draw the dots in circles. We draw top, bottom, right, and left. Each dot represents a valence electron. The core electrons are in there, but we don't need to look at them. We have a maximum of 2 dots per side, top, bottom, right, and left. It doesn't matter if you put the pairs on the top and the bottom, or if you put the pairs on the right and the left, because you could just think about turning the paper around and it would look different. But you have to have the correct number of pairs. And so if you just start and do 1 dot on each side and then pair up as needed, you'll end up with the correct number. So atoms that have 8 valence electrons are especially stable, and we call 8 valence electrons or 8 dots an octet. Just like in choral music, an octet is 8 people singing together. So let's write Lewis structures for the first 10 elements. This hopefully will seem so much simpler than what we just got done talking about. How many valence electrons does hydrogen have? 1. There, Lewis structure for hydrogen. How about helium? 2 valence electrons. But lithium? 3. We're just counting. Beryllium? Oh, I'm sorry, lithium doesn't have 3. Never mind. Don't listen to me. Lithium has 1. Because those first 2 electrons are core electrons now. Lithium has 1. Beryllium has 2. Boron has 3. How many does carbon have? What group is carbon in? 4. 1, 2, 3, 4. Nitrogen has 5. 1, 2, 3, 4, 5. We already did oxygen. Oxygen has 6. You should have 2 pairs and 2 singles for oxygen. Nitrogen has 1 pair and 3 singles. Carbon has 4 singles. Fluorine has 7. 1, 2, 3, 4, 5, 5, 6, 7. And neon has 8. So helium has a duet of electrons. It's got 2. It's happy with that. So hydrogen and helium follow the duet rule. The rest of them follow the octet rule. You look up the number of valence electrons, it's the group number on the periodic table, and you put that many dots around the element symbol. So, in Lewis theory, a chemical bond involves either sharing valence electrons or transferring valence electrons from one atom to another. And the motivation here is to get stable electron configurations. For most elements, that's going to be 8. Ionic bonds involve a transfer of electrons. One atom transfers one or more electrons to another, and then you have a positive ion and a negative ion, and they're attracted to each other. In a covalent bond, you get sharing of electrons. Covalent. Co meaning sharing, valent referring to valence electrons. Sharing of valence electrons. What we call the octet rule is the idea that in chemical bonding, atoms are going to transfer or share electrons to obtain outer shells with 8 electrons. So they're going to do this, sharing or transferring, in order to get 8 valence electrons. Hydrogen follows a duet rule. It's just trying to get 2. Lithium and beryllium are also little guys, and they're also trying to get 2. We're not going to run into them very much in terms of drawing Lewis structures. So write the Lewis structures of magnesium and sulfur. Well, you start with the element symbol. So magnesium. How many valence electrons does magnesium have? 2. So put 2 dots. That's it. Sulfur. How many valence electrons does sulfur have? 6. Oops. It's too big. It doesn't matter where you put the pairs. So, I could do it like this. There's several different ways you could do it. It doesn't matter. But there should be 2 pairs and 2 singles for sulfur.